Hi everyone, this is Girish, and in this video we will be learning about Argo CD, which is a very popular continuous delivery or deployment tool for the Kubernetes applications. Let's discuss a simple CI/CD pipeline for a containerized application. Your developer checks in the code. A CI tool like Jenkins picks up the change, compiles the code, run the unit tests, etc., and then create an image based on that code. And at the end of the CI pipeline, it pushes the image to a container registry, whether it's a Docker Hub or a private container registry like ECR on Amazon, etc. Optionally, after that, it can trigger the CD pipeline, where the image tag that we just created, it actually gets deployed to Kubernetes, and it would have to run the kubectl command from there based on the correct image tag, etc. And your latest code would get deployed to a respective environment. What is the issue with that? Well, one issue is security. On your CI pipeline, now you will have to expose your Kubernetes clusters details. Second issue is again another security aspect where if let's say you're using AWS or some other managed Kubernetes solutions like EKS, in that case you have to also expose your IAM credential or at least some form of access token or etc. So that's one thing. Second problem is now even your developers can actually run a kubectl command and make a change to the existing application. So now whatever you have created in the repo is kind of out of sync with what you have in the cluster. So how do we avoid all this? And that's where Argo CD comes into picture, where it tries to take these pain points out of the deployment workflow. Let's see how it does it. So Argo CD is pull based. When I say pull based, in my previous example, we were creating a repo and then pushing the change or the artifact that got created into the Kubernetes cluster. Whereas in case of Argo CD, we actually install the Argo CD application within the cluster and it keeps monitoring our infrastructure repo. And then whenever it detects a change, it pulls the change. As I said, Argo CD runs within the EKS cluster. Now it can run within the same cluster where your other applications are running, or it can run in its own cluster and manage applications on multiple Kubernetes clusters. Once it's set up, it continuously monitors the manifest files and the changes in the GitHub repo. And Git becomes your single source of truth. What I mean by that is, if you modify the deployment directly using kubectl, Argo CD detects the change and it always makes sure that the Git, whatever is stored in Git, is the desired state. So it just always syncs up to the desired state of the application. We will see it in the demo. So now no more Kubernetes cluster manipulation using kubectl. So we don't have to expose our Kubernetes details to a CI server or even the local host to other developers, etc. Argo CD is also good for policy-based self-healing, which is what we just discussed. Like it would just revert to the desired state, which is in the Git. It also good for pruning. For example, if you change the name of a deployment, then the old artifacts for the deployments are all deleted and new artifacts are created. Here is a simple flow with Argo CD. And if you see, Argo CD application is deployed in Argo CD namespace. Once we deploy the Argo CD Argo CD, we set up an Argo CD application. And that application actually monitors the infrastructure GitHub, which is where we have our Kubernetes Manifest files with the deployments, surveys, namespace, etc. At the end of your CI pipeline, the application CI pipeline, a Docker image is created and stored in a Docker Hub or ECR, and the image's tag version is updated onto the your Kubernetes manifest file. Once Argo CD detects a change in the infrastructure GitHub, it would pull the latest changes and apply those changes to the application that is deployed in the Kubernetes cluster. We will see this all in a hands-on demo. So our demo steps would be something like this. We'll create a brand new Kubernetes cluster which has no application or namespace, etc. created. We'll set up Argo CD. We'll set up port forwarding because I'm using kind utility to create the Kubernetes cluster. So I can access Argo CD UI from the local host. We will create port forwarding or set up port forwarding. You may or may not need it depending upon which cluster you're using. We'll access Argo CD UI and we'll create Argo CD application from a kubectl command. Once the application is set up, we should be able to see how it shows applications, different components of the application within the UI. If we change a manifest in Git, it should be able to apply those changes to the cluster. We will also test some self-healing, like how I discussed. We will change the cluster directly with using kubectl, and Argo CD should be able to revert the changes. Similarly, we will also change the name of a deployment in the Git, and it would prune the old deployment and go to the or create the new deployment. So let's start with creating our cluster. I have all these as part of my GitHub repo as well, which I'll put the link in the description. And if you start, if you go to README file, sorry, this one, and we should be able to see that all the steps that we need to do to run this demo. So let's start by creating our cluster. If I go to, if I say alias k equals to kubectl, and if I say k get node, I don't have any cluster running right now. So we will just start with creating a brand new cluster using kind utility. While it's running, I will show you the Git repo which I want to use for this this demo. So let me go to Git and see. So this has a very simple application. I have application code here, but normally you would keep the application code separate in a different GitHub repo. So in this application, I just have a simple index.php file, which is right now it says 1.2.0, but I have two different versions of this Git. Two different versions of this application created in Docker Hub. So if I go to my Docker Hub, you will be able to see that I have tag 1.0 and 2.0 that we will be able to demo when we change in the Argo CD. So very simple application with just one PHP file and just echoing very simple version. Now this dev infra is basically the folder that we are interested. This is where our manifest file for this application lives. And if I go to namespace, for example, this is our namespace that we will be creating our stuff in. And deployment is very simple. And if you see that default deployment name is my web app in this namespace, and we are using the Docker image with the tag 1.0 and exposing this as a cluster IP service within the Kubernetes. So this is what we will set up our Argo CD to monitor. So let's see if my cluster is ready. So looks like my cluster is all set. So what we will do, let's go to step 2 and we will follow Argo CD documentation from this page to create or install the Argo CD. So let's go here. First, we'll create a namespace called Argo CD. And if we go, this is a brand new cluster. So if I just do kget node, it should have at least one node. Yes. And if I say kget namespace, I don't have the namespace created yet. So I will create the namespace Argo CD. Once the namespace is created, we will apply the Argo CD, this particular manifest, which will install a bunch of pod services, etc. So as you can see that a lot of pod and deployments and some network policies, RBAC, role binding, etc. got created. And we will just watch -n Argo CD get pod, and some of the pods are still creating. So you see that this is the Argo CD server. It's exposed as a service as well, so we can see service. So Argo CD server is the service which will be connecting to from the UI. Once all the pods are up and running, we should be able to connect it. Our next step is actually to set up the port forwarding, because I want to connect from my local host to this kind server. So I'm just going to set up a port forwarding like this. So let's do this. I already have it. So what I'm saying here is from 8010 should go to the 443, which is where Argo CD server is running in my local cluster. Let's check the status of the pod. So all the pods are running now, so we should be able to access the Argo CD UI at this point. So let's try to access the UI. If I go to localhost 8010, okay, connection not private, which is understandable. Great, so our UI is already up now. So the username here is admin, and the password comes from the one of the secret that Argo CD installs. So let's say get secret, and if you see initial server admin secret, we can actually get the password from here. So if I just describe get or just to get secret YAML format, so I got this, but this is actually a base 64 encoded password. So all we can just do this echo and pipe it to base 64 -d. Another way to do is, as I have the shortcut here, is that we can just get this as JSON path and use that JSON path to do the echo the password. So if we do this, it essentially gives you the same thing. So this is our password. So let's go to the UI and enter this password. So we are in the UI, and as we see that there are no application files set up yet. So next step is for us to create our application. I have already created an application.yaml, so we will just go over it and see what it contains. So as you can see, this is API version, kind, metadata, and spec, those four. You must be very familiar with the manifest definition of Kubernetes. Now this actually is a type application or kind application. Project is default, and I'm just using default because I'm just having a simple setup, but you can actually have multiple projects with different names and one project monitoring multiple repos and destinations. So in this particular default simple project setup, I have a repo URL, which is what I want to monitor. And I want to monitor the head revision within the path dev infra. So you can have QA infra or prod infra, etc., depending upon your environment. But if you go back to the Git, we have this dev infra path within the Argo CD demo, which is where our application manifest files live. So destination is local Kubernetes cluster, and in the namespace web dev namespace. And if we go back to if we just get all the namespaces, we should not have this one set up yet. Now Argo CD by default will not be able to create it unless we give it permission. So the way we give permission for it to create namespaces is using the sync policy. Sync policy is a sync option, where we specify create namespace equal to true. So Argo CD, when it tries to run the manifest files from here, and if it finds that there's no namespace and there's a namespace file that is present in the Git, so it will be able to create the namespace. Without this flag though, it will not. Another thing is, we are in the automated section, we are sending or saying self field to true. What does it mean is, it means that if you make a local change to a cluster, as I mentioned in the theory part of this demo, if you make a local change, Argo CD will sync from what we have in the Git if it detects that the local change is different than the value in the Git, because Git becomes our source of truth. And similarly, the prune, if we change the name of an object or a deployment, etc., it would revert it to, or not revert, sorry, it would delete the older objects and create a newer while creating the newer objects. Okay, so this is the application that we are going to set. So we will apply kube. Actually, I'm in the correct directory. So let me just see. Yeah, application YAML is here. So I'll just say kubectl apply -f application.yaml. And what I'm going to do, I'm going to minimize this one so that we can see when we apply this, how the Argo CD application gets created in the UI. So right now there's nothing. And moment I run this, we should have an application created momentarily. Yeah, we should see the application got created. If I click on this tile, we should see that it pulled the data from my manifest files from the Git, and it created the namespace, created a service, and it's still creating the deployment. And the deployment has the replica sets, and we specified one replica set for the pod. So we can see that all in action here, and then we can also see it that our namespace, new namespace got created, and if you see the deployment, etc., for that namespace, get deploy svc and pod, and we see all of these are getting created or got created already. This is nice. And if you drill down further, if you look at the, let's say you want to check the deployment, you click on deployment and you can see the live manifest of a deployment, like annotations, etc. And similarly, if you go to event and the logs, you can see like what's the history on this deployment. Same thing for the pod. And then here it says the pod is running the image with the tag 1.0, which is what we specified. Now we should also see the service, and service has endpoints, etc. So in the service is a type cluster IP, and this is the live manifest of the service. So we should be able to test this service with a temporary pod, and let's see how we can do that. So I'm going to run a temporary pod. This is the optional step, and then we will run the curl command in that temporary pod. So let's see. So I'll go back to my, let me just make it a little bigger, and sorry, let me clear it out, and then let's see. So pod temp1 is already created. So what we can do, we can exec into the pod and see. So I'm in this particular namespace, and we just do exec it into this pod tmp1. Oh, sorry, and then sh. Here we'll just say curl, and name of our service is my web service. So I'll say my web service, and it's printing the service as 1.0. So now the fun part, we will modify this tag to be 2.0 in our Git repo and see if Argo CD able to pick that change or not. By default, Argo CD actually picks the change or posts the repo every 3 minutes. So we may have to wait some time, or we can actually refresh directly from the UI also, which I might do if it takes too long. So let's go here and modify the deployment so that we can change the image tag and see what happens in Argo CD. Changed image tag for demo. Committed the change. We'll go back to the application, and we will wait here for some time and see what happens. So as you see that this it's running the sync right now. So it picked up our changes. It's running a sync, and right now you see 2 pods. One of them is still 1.0, which is getting deleted, and the other one actually got created. Actually is gone. 1.010 is gone. A new replica set is also created, which will eventually be deleted as well. So if you see this, my changes got picked up, and now I see this is 2.0. So we can again test hitting the service again and see if it's returning response from the correct pod. So let's see, if I curl the service again, I should see 2.0, which is great, which is what I was expecting. So as you can see that I modified the manifest file in the Git, and Argo CD picked up, although there's some delay. So there's another way of doing this is from here we can set up a GitHub action which would trigger Argo CD to pick up the changes right away. But that's beyond the scope of this simple demo. Let's do one more thing here. Now we'll stay in the application here, and from the command line, I will edit the deployment, and we see that Argo CD reverts it to what we have stored in Git. So let's see. This is the deployment. So what I'm going to do, I'm going to edit this deployment and make the replica sets, for example, to 2. So we'll do edit deploy this, and so you watch it carefully here. Then for momentarily we will see 2 pods, and then Argo CD kicks in. It's a sync that we specified, self-healing, sorry, and that self-healing makes the desired state, and which is stored in the Git, same as the application, the current state same as the desired state, which is always stored in the Git. So I'm going to change it to 2. As soon as I save it, it will apply the change. And if you see that this is getting to a second pod, and the Argo CD self-healing kicked in, and it says that in the Git you only have one replica, so it created, and it immediately after that it deleted the replica. You can see some of the stuff in the log as well. So one more thing that we want to do is, now we'll try to change our deployment name in GitHub and see if Argo CD picks up that change. So that's the pruning, because if without the pruning it would keep, I don't know, if it might keep the old deployment and the object hanging, but with pruning, if you change the deployment name, it would actually delete the older artifacts. So let's do one more change here and make the name as the web app, so that it makes the correct change. So let's say change deployment name for demo, and I commit the change here, and I go back to my Argo CD application, and let's see if it picks up this change. So if you see that it's took a minute or minute and a half, but it started picking up the change where it created this new deploy with web app, and it removed the old deployment that was with my web app, and everything else remains the same. So that's all for this demo, and I really hope you like it, and I will see you next time. Please like, share, and subscribe for more Kubernetes videos like this. Thank you so much. I will see you next time.